Let's return to a question that we talked about early in the class in the second module, the question of how many firms fit in a market. Just thinking back, the very first module we developed the market demand curve, and in the second module we talked about the cost structures of firms and firm supply. And an interesting question that got set in motion with those two ideas was the question of how many firms fit in a market. And we've talked about the polar extreme examples when lots and lots of firms fit and the products are homogeneous, that's perfectly competitive. When just one fits, it's a monopoly. But now actually the point I want to make in this set of slides is that we have a model for thinking about the continuous range in between. So let's come back to that. So again, how many firms fit in the market? Let's work through a specific example. Let's say that market demand is P equals 100 minus Q, which we've seen before. And now we'll say that the total costs at any particular firm are equal to 800 plus 10 times Q. Let's think for a second about what that cost structure means. It means there are fixed costs of 800 and marginal costs of 10 per unit. Well, the first question we can ask as we think about how many firms fit in, let's just think about considering numbers of firms from 1 to numbers bigger than 1. So 1 means a monopolist, and we can ask, is it profitable for a monopolist to operate in this market? To answer that question, we just have to figure out what a monopolist would be doing here, that is what quantity they would produce and what price and their profits and so forth. So we do that by finding the MR, marginal revenue for this firm. It's 100 minus 2Q. Setting MR equal to MC means setting 100 minus 2Q equal to MC, which is 10. If we solve that, we find that Q is 45, and using the demand curve, we can find that P is 55. So that's the solution for a monopolist. Now let's ask the question whether the monopolist's profits are positive. There's P times Q minus Q times MC minus FC, and it turns out it equals 1225, which is bigger than 0. So yes, indeed, it is profitable for a monopolist. So 1 might be the answer to how many firms fit in the market, but we also have to think about numbers bigger than 1. And so here we are, thinking about that question. Is there room for another firm? Now, before we do math, let's just kind of talk about this at some intuitive level. Let's suppose, what if prices remained at the 55 level that they were with a monopolist? Now, by the way, that's unrealistic because more firms would bring about more output and lower prices, but let's just start with the idea that the price remained where it was. Well, if so, would there be room to cover another firm's fixed costs? Well, the answer is yes, because profits were $12.25 with a monopolist, and that's bigger than the $800 it would cost for another firm to get in. And so the profits at the monopoly profit could cover the fixed costs of another firm. So that's a bit of a hint about the answer, although it's not really the answer, because to really answer whether two firms can fit, we need to know what would happen with duopoly. What would be the price and quantity, and would each of the two duopolists be able to cover their costs and have positive profits? So this was just kind of a reality check. Let's think it through intuitively, but now we'd actually like to solve the problem. So to do that, we need to find the duopoly equilibrium. Of course, this is familiar. We've done this a number of times during this module. Not these slides, but earlier slides. Anyways, let's talk it through. Market demand curve is 100 minus Q, but Q really is the sum of the output at firm 1 and the output at firm 2. So that's the demand curve overall. The marginal revenue curve for firm 1 we can write in this way, where this first chunk here is the intercept, and then here's the bisecting business, so we have minus 2 times Q1. Setting MR1 equal to MC just means setting this equal in this case to 10, because MC is still 10 in this problem. And that finally gets us to this expression for firm 1's reaction curve. If we plug firm 2's reaction curve into firm 1, from 1's reaction curve, we end up with an expression just involving Q1. We can solve it, and we find that Q1 equals 30. And this problem's symmetric, so the same is true for Q2. And just stepping back for 1 second, what are we doing here? We're finding the Nash equilibrium, or the Nash and Cournot equilibrium, for the simultaneous move homogeneous products game. In any event, though, if Q1 is 30 and Q2 is 30, then overall Q is 60 and the price is 40. So that's the duopoly equilibrium, but we still have to ask whether a duopolist is, each of the duopolists is profitable. So here we are asking that question. Are the two firms profitable with the Cournot-Nash equilibrium? So as we just said, the quantity is 30 per firm, and that means the price is 40. Just as a reminder, why is that? Because P on the demand curve equals 100 minus Q1 minus Q2. 100 minus 30 is 40. All right, so the per firm duopoly profits, well, what are they? Profit equals, there's the price, P, 40, times the quantity at each firm, 30, minus fixed costs, minus MC times Q. And we end up with 1200 minus 800 minus 300, and it equals 100. So yes, that means each of the two duopolists is profitable, and yes, there's room for two in this market. So the answer is not one, the answer is at least two. Now we can keep going. And we can ask, does a third firm fit? Well, first way to go about this, let's ask, suppose prices did not fall from the price level of 40. And this is, again, kind of an overly optimistic assumption, because we do believe that with more firms, output would increase and prices would fall. But just as a way to think this through, kind of first pass way to think it through, let's say prices didn't fall. Then what would revenue be? Well, if prices were still at 40, then if we're on the demand curve, quantity has to be 60, so the revenue would be 2,400. Now, because marginal costs are 10, that leaves 30, 40 minus 10, as what you might call the contributions to profit. Really, it's just the P minus MC times Q business. So 30 times 60 as the contributions to profit before the fixed costs. And what does that stuff equal? Well, it equals 1,800. Now, how many firms' fixed costs could that cover, given that fixed costs are 800 per firm? Well, it certainly can't cover 3, because 3 times 800 is 2,400. So there's no way that 3 firms are going to fit, especially because when a third firm actually enters, the prices will end up being lower and the quantities higher, the overall revenue lower. So the answer, since we already found that 2 could fit, but now we're seeing that 3 cannot, is 2, but not 3. All right, what are the takeaways from this module? Well, the first thing I think is just to revisit our Module 2 question with more artillery. In some sense what we're seeing is we've learned quite a bit since then. And so we can come back to that question and answer it, in a pretty satisfying way. Now, what is it that's going on in this answer? Well, the following. There are 3 underlying things in this bullet point, and I'll underline them again, but market demand plus the cost structure of individual firms, along with a third thing, a way of determining the equilibrium. That stuff altogether tells us how many firms fit in a market. Now, an important intuitive point is that higher fixed costs means that fewer firms can fit, and vice versa. And then I guess the final point is that the Cournot model that we've been working with in this homogeneous goods duopoly set of slides, the Cournot model basically fills in the space between monopoly and perfect competition with, as the number of firms is kind of countable and small, then grows, we have a way of thinking about what happens to prices, quantity, and profits, and so forth. And, as the quantity of firms in the market, number of firms in the market approaches, a large number, even this Cournot model ends up looking like perfect competition.